so we're doing our second lesson today. We are going to graph linear equations, and we're also going to determine the slope and the y-intercepts. So again, we have seen this before, but it's super important, so we're going to go through it again. Alright, so last class we graphed ordered pairs, and today we're going to take this to the next level. We're going to look at graphing lines. So just some interesting things about lines. Every line has a steepness. Okay, so I've got my black line here. You can see that I've put it's a little bit faded, but there's 2 points right there and there. We could also have lines that look like this. So it's a vertical line, which you guys haven't seen before. A horizontal line, also haven't seen before. Or we could have something that looks like this. So the difference between the black one and the last red one that I drew is the last red one that I drew went from left to right down, and the black one goes from left to right up. Okay, and those are just lines with different types of slopes. Okay, so each line has a different steepness. We also call this the slope. There are two different types of intersections that we have on our graph. We have what we call the y-intercept. And the y-intercept is where our line crosses the y-axis. So right here, this would be considered as the y-intercept. Okay. We also have what we call an x-intercept. And this is just where the graph goes through the x-axis. So where the line goes through the x-axis. And this is called the x-intercept. To draw a line, you need to have at least 2 points. So notice if I just have 1 point, I can draw lines through it with any type of steepness. There's nothing really significant about that point. But every line has its own distinct steepness, and therefore if we have 2, then we have to draw the line through here. There is no other way of drawing a line through both of those. We could have more points, of course. We could have 3. Of course, the line will go through all 3. We could have 4. We could have as many as there is. A line is, in fact, just made up of an infinite number of points. And notice, as I draw these closer and closer together, I end up with a line. These lines have an equation which can be used to find points to plot the line. We call this a linear equation. Okay, so all these are is linear equations. There's lots of different forms. So we have slope-intercept form. We have standard form. We also have general form. Okay, and this is ax plus by plus c is equal to 0. Okay? So there's lots of different forms. Now, the one that has the most interesting things that come out of it is actually our slope-intercept form. And as you might recall from last year, our m is actually our slope. If you remember, slope is equal to the change in the values of y over the change in the values of x, or we just said rise over run. We'll talk about that a little bit more. And we also have this value b, which is our y-intercept. So it's nice that we have these formulas, but what do they really do? So let's actually do an example. Okay, so we have graph the following equation, y equals 1/3 x plus 3. Now, looking at from up here in our equation, notice that 1/3 is equal to m, so m is equal to 1/3. This is in, sorry, I should have said this is in slope-intercept form, mx plus b. So this means that my steepness is 1/3. Or we could say our slope is 1/3. And this is, remember, slope is just rise over run. Or change in x, sorry, in y over change in x. Okay, and then we have 3, which is our y-intercept. Alright, so the first way we're going to plot this, the first way we're going to graph this, we're actually going to use a table of values. So the first step is to actually create a table of values. Okay, so this is my table of values here. Table of values, we do a little x, and then we have our x values and our y values. Now, we have to choose at least 2, but 3 is better. So choose at least 2 values of x so we can find y. We want nice values. Okay, so a nice value to start off with, 0, is super easy. Okay, I'm going to just do it over here. So I've got y equals 1/3 x plus 3. If x equals 0, then I'm just substituting. So 1/3 x is 0 plus 3. Well, this means that y is equal to, 1/3 times 0 is 0, so y is equal to 3. So when x equals 0, y equals 3. This is an ordered pair. Okay, you can also write this as 0, 3. And so we start at the origin. Now, x is 0, so I'm not going any direction on my x-axis because it's at 0. That means I stay there and then I go up 3. 1, 2, 3, and I plotted my point. I'm going to erase my little squiggles, and of course I'm going to label it 0, 3. Alright, let's choose another one. Now, x is being multiplied by 1/3. Okay, we don't want fractions because our graph doesn't have fractions in it. It has whole numbers. So I want to make 1/3 times something equal a whole number. So we need to multiply by some sort of multiple of 3. Well, let's just take 3. So if x equals 3, then y is equal to 1/3 multiplied by 3 plus 3. Remember, 3 is just the same thing as 3 over 1, and therefore this will simplify to 1. So we get this is equal to 1 plus 3, which is just equal to 4. So if x equals 3, y equals 4. And again, this is just an ordered pair. It's saying 3, 4. So I start at the origin and I go 1, 2, 3, and then I'm going up 1, 2, 3, 4. Okay, we're going to do a third one, and the reason we do a third one is because if we make a mistake with our algebra, we'll notice that when we do our third one. So let's choose the negative side of 3, right? So negative 3. Okay, we already know that 3 times 1/3 is a whole number of 1, and therefore, if I just have a negative in front of it, then I'm just changing the sign. So if x equals negative 3, then y is equal to 1/3 times negative 3 plus 3. Well, this is going to simplify nicely to negative 1. So I end up with negative 1 plus 3, which is equal to 2. So when x equals negative 3, y equals 2. Again, this is just an ordered pair. You don't have to write out the ordered pair every time. I'm just writing it so that you guys can see that. I start at my origin. I count 1, 2, 3, and up 2. 1, 2. I draw in my point. I erase all these squiggles, and I draw my line. Now, we're not perfect at drawing lines. I'm not even going to pretend that I am. So we just draw it as best as we can. I forgot to label my points. We do want to label each of our points. Do that now. Every time you draw a line, make sure you label your points. And the final thing that we need to label is actually our axes, or sorry, our line. So y equals 1/3 x plus 3. And we're done that one. Alright, just some points of interest here. So we're going to skip the x-axis. We'll do this another day, just because it's more complicated with this one. So what is the y-intercept here? Well, the y-intercept occurs, and we did talk about this above, but notice that it goes through the point 0, 3. Oops. 0, 3. And we say that the y-intercept equals 3. Okay, and this is what we saw up here. The y-intercept was 3. How could we use the y-intercept and the slope to draw the line using a different method? So we're going to do this for the next question, but it's a useful question. I want you to think about this. How would you use the y-intercept? Okay, so this is what we just plotted with the yellow. How would we use that y-intercept there? And the slope to draw the line, the same line, using a different method. So we're going to use this idea to do the next one. So I have my graph y equals 4x minus 5. Again, this is in slope-intercept form. Okay, y equals mx plus b. So my y-intercept is equal to negative 5. Okay, so this means that my y-intercept always occurs when x is 0, right? Because the y-intercept occurs along this line. There's no horizontal movement. And my y value is negative 5. So I can just put this in right here. So this point here is 0, negative 5. Now, I can use my slope to actually find the next point. So our slope here is equal to 4. Okay, we can rewrite this as 4 over 1, right? Because anything divided by 1 is itself. So using that, though, we have the change in y over the change in x, which is also just rise over run. So we're going to use this. So if I start at any point, to get to the next point, I'm going to go up 4. Maybe I'll write it down here. And I'm going to go positive 1. So to get from my next point, I'm going to go up 4, 1, 2, 3, 4, and I'm going to run 1. And I'll put that point in there. And I'll erase these ones. Oops. I'm going to label this. It's clearly, you can see that it's gone over 1, and it's gone up 4. And my new graph looks like this. And I want to label it y equals 4x minus 5. You can do either way, either method. You can use your table of values method, or you can use the y-intercept and the slope to calculate. Now, you're not always going to have your graph in your y-intercept form. It might be in the standard form, or it might be in the general form, and so you have to figure out how to use those, and the table of values is the most used one. And we're done.